All right, I think we can get started here. Yeah, so last week we talked about RAG. I was working on this example where we applied RAG to Game of Thrones, and it didn't do that well. I felt like I was kind of disappointed by its performance with our handful of example questions that we tried. It got a couple right. We asked it who Arya's father is and how many children Ned and Catelyn have. They've got 5 and then one illegitimate son. So 6 is a decent answer. But they got several wrong. At least 2 of these are pretty. These are sensible answers. They're just incorrect. That's a cast member and that is a valid character, but they're not the right answer to those questions. This one's just totally. It's like, I tried searching like is there a character named Caspian in Game of Thrones? No, that's C.S. Lewis for sure. I did find that Peter Dinklage plays a role in the Prince Caspian movie. So there's like that link, but otherwise, yeah. So that one's a hallucinated answer. So I was supposed to just kind of like polish off that notebook, but I kind of indulged myself and I looked into adding some additional reference material to see if we could improve the quality of the results that we were getting, the answers. So yeah, because the original example, we just had, we took a data set from a library called Haystack. They had something like 400 articles that came from regular, wikipedia.org. But I know there's a Game of Thrones wiki out there. This is like the Fandom wiki. Lost the URL apparently. There we go. So I really wanted to like pull this in to see if adding a much richer database of reference text would help with the problem. So most of what I've got today, is kind of related to my experiences trying to do that. And I think there was some kind of interesting stuff in there that does seem like broadly applicable. So I thought it'd be worth sharing. Yeah, so I just covered that. All right, so scraping is kind of its own topic, but there is to start with, there's a tool called Wiki Extractor. Appears to be enormously popular, and it's a Python script that will grab text for you from a Wikipedia database dump. So that's cool. And I was able to find that, so Fandom hosts wikis for different games, different nerddom stuff. And there is, for each wiki, they do actually periodically generate dump files. So that's cool. You can find them on like the statistics page. So here's the, yeah, so they make these database dumps. It's a little old, but they've got one here. However, if you try to download it, you get an error message. And so it's hosted on Amazon on S3, but it's in a deep archive. So it's in Amazon Glacier, which I think is like tape drives. So you have to, before you can actually like access this online, an administrator has to go and change the storage class from deep archive to S3. And then after a couple days or something like that, they get it back on S3 for you. So couldn't use the dump file. That sucks. But I figured like, all right, like scraping, that's such a common thing to do. Like it can't be that hard. There's got to be some good tools out there, some good example code. And that's halfway true. There's a Python library called Wikipedia that actually makes scraping Wikipedia easy. You can just kind of give it the name of an article, and it'll help you access the text in it. But it doesn't, as far as I can tell, it doesn't help with scraping other wikis. So that didn't cut it. So you can just Google like scraping a website with Python, and they all seem to use this library, Beautiful Soup. It's an HTML parser that helps you interact with the elements in a web page. So I had some fun. Again, this is like, this felt hobbyish or something. It's like a fun distraction. But yeah, so I wrote some scraping code. It uses requests and Beautiful Soup, and you kind of do like I did it recursively first, where you kind of crawl. So you start on a page, you grab the text from it, and then you grab all the URLs, and you can recursively like scrape those pages. But that's a bad idea because it creates this really deep stack. Eventually you run out of memory and it crashes. So it looks like the right way to do it is with more like stacks. So I have like a stack of URLs that have been scraped and a stack of URLs to scrape. So you just keep looping while there's, as long as there's stuff in the to-do stack, you keep going, pop off the next URL, retrieve it with the request library, send it through Beautiful Soup, and then you can start parsing it. So I was surprised that like that I didn't find better example code for like pulling out the text from a web page. So kind of what I landed on, and this seems to work pretty well, is if you find all of the HTML elements that are either like headings or paragraphs, that seems to do a good job of grabbing all the text. So basically what I did is for each paragraph, each heading, I just add a blank line in between them, and then write each of the articles out as a text file. So yeah, and then so that grabs all the text, and then this is kind of the crawling part of the function. So grab all the links, and then filter out a lot of pages. Kind of just gradually built this list as I looked at what articles it was pulling out. So there's all these different article types that like don't actually contain content related to the show or the series. So yeah, so if it passes those checks, then add it to the to-do pile. And yeah, this works well. So there's like 5,000 roughly articles on the wiki. Pulled them all down. I love this, the very last one. Game of Thrones, the musical. Really, guys? Let's see what it says. "12-minute sketch produced." Okay. Oh, interesting. Wow. All right. Anyway, I'm not going to get distracted by that. Cool. Yeah. So let's go back to my notes here. So that's the scraping code. That worked out okay. Right. So here's where it got to some issues that I feel like this is probably relevant, to everybody, not just web scraping, but everyone trying to do question answering, I would think. Let's see. So the formatting the article text is kind of an interesting challenge. Let me see where I've got the. Right. So here is. It's pretty small. Can we? Yeah, there you go. So here's the output of my scraper. You can see like headings in here. This is good. It seems to be picking up. This looks like kind of tabular data here that it does seem like it's grabbing. Let me see if. Let's take a look at that web page. So here's the actual article. Lots of ads on here, sorry. Yeah, so it managed to grab this. That's good. It seems kind of table formatty, but I guess what I found interesting here is like, how do you, with headings especially, you know, how do you present those to BERT? How do you, because they seem really important, right? They give a lot of, oh, sorry guys, truck noise. They give a lot of meaning, right, to the text. They tell you like, this is kind of what this paragraph is about. So something I haven't done yet, but I might try is to maybe like, for each passage, maybe add the article title, add the heading to the article title. So when you feed the reference text into the encoder for DPR, the retriever part of the RAG model, you give it both like the article title and the text. And I'm thinking maybe having the heading in that title could add some insight.
Yeah, I've seen that kind of technique where, because it's a long article and you have to break it up into maybe 10 chunks that can be processed through something like RAG, then you append to the very front of each one a very generic title that sort of helps it along when it's looking at, you know, similarity comparisons or something.
Nice. Okay. Yeah, and then I did see. So one of the questions we asked that it got wrong was, you know, who did Kit Harington marry in 2018? And the Game of Thrones wiki has the answer to that. I'm not sure if Wikipedia, if the Wikipedia data set has the answer, because it didn't actually include, the article on Kit Harington. So yeah, this says they were married in June 23rd, 2018. So hopefully, I haven't gotten. So we'll see at the end of this that I haven't gotten this all working yet. So I haven't been able to try it out to see, you know, if it gets this right. But this felt like some good confirmation of like, all right, yeah, I think this ought to help and get us some better results, and that would be nice, because it was, yeah, it's sort of a bummer to like, you know, be investigating this model and then to like have it only get 2 out of 6 questions correct. It sort of saps my interest in it, I guess. So I want to see it do better. Yeah, so headings, I'm pretty sure tables are missed. Let's see if we can find an example of that. Gonna randomly walk here. Yeah, it could take a while, but I'm guessing the tables are missed, so that kind of sucks. I know that's a whole like area of research with BERT. It's like creating models that try to make sense of text formatted in tables. Tables can be really great sources of info, but yeah, a little unnatural for BERT. So headings, yeah, we talked about that. Yeah, another issue I saw is like, we look at, so this is a particular episode of the series, and it's a list of characters that appear in the episode. So it's like, it's this giant list, and I think if you once you chunk this into passages, right, like the meaning of the list is going to get lost. Although maybe not, since you have the article title, at least you have the fact that it's appearances. But yeah, so I'm guessing there's other situations like that where like a chunk of text like on its own is not very meaningful. You kind of need to know its context in order to make sense of it and access the information in it. So it seems like another challenge. Cool. All right. And then, yeah, let's see. I forgot to add a section on this. So let me do that now. So what stopped me from kind of the problem that I'm stuck on currently that's preventing me from actually running this example is that somehow the data sets library, when I use the load dataset function, is resulting in duplicate copies of the data set. So it's something like, there's like 5,000 articles chunked into something like 46,000 passages, and then the data set ends up with 92,000. It's been driving me a little crazy, but I'll keep looking at that. Is there anything else to say about that? Probably not. But that's kind of what's blocking me. And then the other aspect, should I put that in here? Yeah, the other thing is like the encoding speed is kind of slow. I considered like, well, maybe I just roll with it and let it encode, 92,000 passages instead of 46,000. Just get on with it. But the encoder's been taking forever. Let's see what I've got here on that. Might not been like creating copies of the notebook to like explore different parts of it, and starting to spin out of control there. So I'll see if I've got see if I'm looking at the right one here. No, that's the smaller data set. So that one's manageable. But yeah, so 10x, that should only be taking like 20 minutes, but I'm in more like the, I don't know, hours range or something. I've also been getting less powerful GPUs from Colab lately. Let's see. So I can find that in here. Keyboard. Not found. All right, so maybe that's why this one ran quicker. Did I get a V100? No. There we go. Oh yeah, no. Yeah, Tesla T4. So yeah, I'm curious if like the chip shortage or something is like starting to increase the demand on Colab GPUs. Nope, nothing there. What else? Okay. Yeah, I did figure out the last week we were looking at the DPR model, and there's kind of like two options for the pre-trained DPR model. There's look at that again. Let's see. Right, okay, load the GPU, DPR context encoder, there we go. So there's single NQ and multiset. And I figured out from the paper that the single NQ, single means it was just fine-tuned on one data set, and in particular, it's the natural questions data set. And then multiset means that it was trained on, I think all the first 4 of these. They said they didn't train on squad. And then they did, this first column is like how many examples are in the data set, but then they did some filtering. So the second column is like how many examples they actually used. But what I saw on the Hugging Face models, yeah, so you can see, right. So this, oh, that's tiny though. So single NQ has been downloaded 130,000 times over the past month, but the multi-set one is only like 5,000. So I feel like that's a good indicator that we should be using the single NQ one. So I changed the notebook to do that, but I guess I haven't checked yet whether that improves the results on our original questions. So I'll have to run that. The single NQ. Yeah. And then, excuse me, I did also, another thing that I had kind of incorrect last time. So to do like an example search, which I think is kind of interesting because you can like run DPR on its own, do a query, and see what comes back to see like, do the results actually contain the information necessary to answer the question? And that can kind of give you an indication of like, is DPR the problem? Is the retriever not doing its job very well? And so that's why the questions are wrong, or the answers are wrong. So to test that out, there's actually, DPR uses 2 separate encoders, one for the question and one for the context passages. So in order to kind of test this out, you need to load up the question encoder as well. Yeah, and then it's got its own tokenizer. I imagine they're identical, but just to be safe, loaded the question encoder tokenizer. Let's see. Yeah, so that's encoding the question. Who's Arya's father? Search the index. Let's see. Yeah, that's all my development code. Shouldn't show you guys that. It's too messy. Yeah, so this is what it came back with for who is Arya Stark's father. So it pulls up the Bran Stark article, one of her siblings, and it does mention that he is the son of Ned Stark, and one of his siblings is Arya. So a little roundabout, but the information is there. That's good. Some of these other ones, well, yeah, I guess, right. Yeah, same kind of deal here. So Jon Snow, also son of Ned Stark and sibling to Arya. Yeah, it's not bad there. Yeah. And then I think that's actually all I've got. So where are we at today? Yeah, like 30 minutes, 20 minutes. Not bad. Next steps, I'd say continue debugging the load data set issue. I looked at like both the CSV file for the chunked version of Wikipedia and the CSV file for the Fandom wiki. Don't see really any differences, so a little stuck there. But I might try like manually creating the CSV. And then, right, try out single end queue on the Wikipedia data set, original questions, any better performance. Yeah, and then run whole thing using the Fandom wiki. And then, of course, polish the input. Cool. Anything I'm missing there? Guess the headings, perhaps. Yeah. Anything else you guys think I should try or explore in the notebook more?
Chris, did you try to load it in pandas first and then from pandas to dataset? Because from pandas to dataset, it's fairly straightforward. And when you load to pandas, you have more control.
Yeah.
Just a suggestion.
Yeah. Cool. Okay. Right, because I've loaded the data set with pandas and it loads it correctly. It gets 46,000 rows. So
right, and then dataset has from pandas, so you can just
nice. Okay. Cool. I'll try that. Thank you.
Hey, Chris, did you notice, is there any difference between scraping the data set versus scraping the live Wikipedia site? Is it pretty much the same thing? Like, in other words, you're not going into live Wikipedia to get this stuff, right? You're just getting it from the data set?
Let's see. So yeah, so the scraping code is, I ran against this, dedicated Game of Thrones wiki. So it's separate from Wikipedia.
Okay, right. But I mean, this one is live. Are you actually going out to this wiki site and getting it from there? Or is it just something that's already been aggregated into, gigabytes that you're downloading without actually straining the server?
Okay, no, I'm straining the server. It strains it slowly. It's not too bad.
And nobody else at you.
I guess took, executed in, dang, what is that in seconds? It's like, or I'm sorry, in minutes. Is it 90 minutes? Something like that, 80? Yeah, 80 minutes. So it took a while to do this, and it does like, I don't know, 1 per second roughly or something. So
okay, so you're not digging into into a database. You're actually going to the live server to get this stuff.
Yep. It'd be really nice if I could download their pre-generated dump file, but
Sure. Right.
I thought about trying to contact one of the like administrators of the site, see if they'd pull out the dump file for me, but I didn't want to wait on that.
Yeah, it's the deep archive. That takes probably a day at least.
Yeah.
Good.
Dimitri, are you working on a question answering application? Sounds like you're pretty familiar with the datasets library.
Not specifically. I'm more on, like, text classification
Okay,
side and entity extraction.
gotcha. But you've worked with the Hugging Face datasets library.
Yeah.
In that.
Hugging Face dataset, we're loading data into it for classification, and we found that pandas is the best way to do it, since you're controlling exactly what you load, and you can see it nicely formatted and massage it before you get it into dataset.
Cool. All right. Yeah, well, I think we can just wrap it up there. I think I'll stop the recording here, and if you guys want to hang out more, we can got extra time here, so we can we can sit and chat if you want. But if you want to drop off, thanks for being here, and we'll see you guys in the next one.
Thanks, Chris. Appreciate it.
Yeah.
Thank you, Chris.